In this video, we will take a deeper look at structuring data from realistic and sometimes complex experimental records using Augmend. To demonstrate the use of Augmend, we will be using 5 experimental write-ups from a shampoo formulation lab. So here on my screen, I have the 5 write-ups. The first write-up is a more informal kind of write-up, which hardly has any structure, only a vague structure along some of the things to do. There's no structured data at all in this write-up. The next write-up is from a pilot plant batch record, which is also in a narrative format, but it has slightly more structured data, for example, the formulation in the form of a table. And the flow of the document is more on the lines of a process, which is typical for a pilot plant setup. The third experimental write-up is a more structured entry, like a lab notes entry, where the key formulation data is tabulated and the rest of the document also follows a certain pattern. In each of these 3 documents, we just have one experimentation. And in the next 2 of those documents, we now have multiple experiments in one document. So here we have 3 different process explorations for one formulation. So the formulation is listed here. And 3 different processes were tried, where first part of the process was similar, and the downstream process was changed to see the influence of process on the product properties. And the last part is maybe a more typical prototype exploration kind of exercise, where we had 3 different prototype formulations, which were made in the same way, and then the product properties were measured to see which formulation is favorable. Now, to process these 5 documents, what we need to do is upload them into the app using this upload button. So I'm already in the app. I've used the upload button to upload these. They then get automatically extracted, and the results can be downloaded into Excel. Given that in this demo, we are going to focus much more on the results, we are not going to look at how the app works, and we are straight away going into the Excel where the results are located. So here I'm sharing the Excel with the extracted data. We have a huge number of data points extracted in these sheets, resulting in a very rich data extract. I'm going to take you through some of these sheets and highlight some of the key extraction points. So the first thing is just some metadata on the document itself, the name of the document, etc. The next sheet is some very important metadata on each of the experiments. So you have things like the title of the experiment, the ID, who conducted the experiment, on what scale, what was the objective of the experiment, maybe the hypothesis behind it, what was the consumer benefit. Of course, all these can be adapted to your needs. These are the ones I've chosen. And there are quite a few more, which I'm not going to go through right now. Then you have some metadata on formulations. So if there is any kind of product line that is mentioned, that will be captured here. If there's any brand name, that will be captured here. Then we have data on individual experiments. So here is data of all the equipment that is mentioned in each of the experiment, which you see here. You can see here the raw name of the equipment. If a model name is mentioned, that will be populated here. And if there is any internal ID, that will be populated here. Now imagine that you have a huge number of experiments and you want to very quickly sift through the experiments where a certain kind of equipment was used. That would be made possible through this kind of data extraction. You don't have the data on individual variants or individual prototype formulations that were made in the different 5 experiments, and here you have some data associated with that on what was the variant name, what were the observations, etc. on each of the variant. Here you have information on material usage within each of the variants, so essentially quantitative formulation in each of the variants. And here you can clearly see that the values have been separated from units. So if you imagine now you have this for thousands of experiments, you can really do quantitative analysis on this. You also have similarly the measurements made on each of the prototype. So these are basically, once again, values separated from units and some other metadata associated with that. This, by the way, we can standardize, and here the terminology has been standardized to shampoo investigations. Then we have all the process steps. So you can basically look at the sequence of steps that was conducted for each of the variant. And finally, the coolest maybe what you could extract is the relation between independent and dependent variable. So in each of these experiments, what were the independent variables and what were the dependent variables. Once again, here we have standardized the terminology, and what you see here is basically pairs of independent and dependent variables, and some of the quantitative information on how much variation was done in independent variables, and what the units are. If you imagine now this kind of data collection over thousands of experiments, this is almost like an oracle, which people can consult, to understand what would be the effect of whatever they are trying to investigate. I hope this short demo gave you a good perspective on how you can leverage your historical R&D information using Augmend. From simple things such as tagging your experimental data with batch numbers or raw material names or equipment names, you can search them much, much easier. The real benefit of Augmend, however, is in enabling quantitative insights. To give you a couple of strong examples, you can design a recommender system. Say a system which recommends formulations, because now you can link up the information on prototypes as well as physical property measurements or chemical property measurements across thousands of different experiments. Second thing you can do is in-silico experimentation. Now you have the relationship between your dependent variables and independent variables across thousands of experiments. With such kind of tools available for your scientists would naturally gravitate towards using such tools rather than repeat experimentation. And this is the key to accelerated innovation.